Hi, it's Doug Schneider from SoundStage. Welcome back to another episode of Real Hi-Fi. Now, I've taken a long break to work on other projects, but I'm back with what I consider a dumb topic to make a video about. Do speaker driver materials make a difference? And the reason I think it's a dumb topic is because, of course, they make a difference, a big difference. But I've been seeing online in forums and even in videos that there are people, and people who should know better, who are saying, well, they make no difference whatsoever. It could even be chalked up to marketing or just audiophile nonsense. Well, nothing is further from the truth, because the speaker driver materials, and these people are often talking about the diaphragms, in other words, the cones and the domes on drivers, having no effect regardless of what they're made of. And the reason it's far from the truth is because you can see the results of these materials showing up in measurements such as frequency response charts that are also very audible. So for those who don't know, what a frequency response chart will show you is the relative output level for the device under test across a broad range of frequencies. And for, say, an amplifier, unless it's a really poorly designed amplifier, it will be flat. And what that means is across those frequencies, the amplifier is outputting the same level for each frequency. In other words, the same loudness when it comes out of the speaker, say. And that means it's accurate. But if you look at the frequency response of every speaker out there, it'll be far from flat, whether you're measuring it on axis or off axis, or you're combining a bunch of curves. You're going to see a lot of little squiggles up and down, some big, some small, but a lot of them. They are very imperfect devices. And the reason they're imperfect devices is because even in a very well-designed loudspeaker like this one, the Paradigm Founder Series 100F, it does have pretty flat frequency response. It's a big ask to get all these drivers combining correctly. And I'm not going to get into the design of a loudspeaker. That's a whole different topic. But suffice it to say, loudspeakers are not like amplifiers. There's a lot of variability when it comes to the design, even today, even for the best ones. But when it comes to all those little squiggles, that's not all due to the driver materials. Like I said, it's a big ask to get these all working together. It has a lot to do with the cabinet, its size, its shape, the driver configuration, the crossover, and what I want to talk about, the driver materials. It's one part of the equation. So let's imagine a theoretically perfect loudspeaker, a loudspeaker that does not exist. Designers simply try to get close to the ideal. In a theoretically perfect loudspeaker with multiple drivers, what you would have is no contribution from the cabinet, no diffraction effects or resonances or anything like that. And you would have drivers that simply move the air, and their movements would only be of the air, and there wouldn't be any movements within themselves. So if you notice, I flexed my fingers there a bit, wiggled them. And that was to simulate the diaphragm, it wiggling and flexing. And why did I do that? Well, because diaphragms in an ideal world would stay perfectly shaped as they're moving the air. But unfortunately, like there is no ideal loudspeaker, there is no ideal diaphragm. They all have, let's call them, flaws. Even the stiffest material, you might be surprised how much it flexes when they start examining it with lasers and stuff like that. I was shocked to see even a metal diaphragm that I thought was really stiff and couldn't lose its shape, losing its shape somewhat as it drove certain frequencies and to certain output levels. And you can imagine a soft material, say polypropylene, you can flex it. It's going to flex as it's moving the air. The drivers then aren't simply moving the air pistonically. They're imparting their own signature through the materials they're made of. And these material signatures show up in measurements such as frequency response charts that you can, in turn, here. Now, I don't want to get into all the materials and this and that. I'm not a mechanical engineer. I'm not a material scientist. Go talk to one of them. But I do want to blow away this notion that materials don't matter. It's all marketing or audiophile foolery by using a simple example, tweeters. So until sometime in the 1980s, materials for tweeters were generally soft materials, plastics or silk or something like that. Then in the 1980s, metal domes started coming in, and metal was heralded because here's this super stiff material, and depending on the metal, light, that could hold its shape better than a soft material when reproducing those high frequencies at high SPLs. And they can look at these things, like I said, with lasers today, about how a material holds its shape as it's reproducing these frequencies. And before I go on, I do want to say, because somebody will call me out on this, that how well a dome holds its shape doesn't only have to do with the material it's made of, but also the shape of the dome. That has a profound impact as well. But the material does as well. And when it comes to metals versus a soft material, the soft material doesn't ring like metal does. Take a piece of metal and hit a piece of silk or plastic. It doesn't give a bell-like sound. It will deform. It will make resonances at low levels across a broad range of frequencies, but then hit a metal like you would use for a metal dome tweeter, and it will make a metallic sound. And what happens to metal at a certain frequency is it will ring, and oftentimes ring violently. And the earliest metal dome tweeters rang violently within the audio band. So they would hold their shape nicely, except at a certain frequency, it would just go off the charts and come down like that. And that amplitude increase comes straight to your ears. Now, that was the early metal dome tweeters. And over the years, the designers of these drivers worked and worked and worked to mitigate this bad resonance they were known for. And today, the best metal dome tweeters ring quite violently still, but well above the audio band, some as high as 30, 40, 45 kilohertz I've seen. So we can hear to 20 kilohertz. This ringing behavior happens way up there. That's a good thing. They've pushed it out of band, but that still means that in band, it's behaving differently, more pistonically, than a soft dome tweeter. The soft dome tweeters, the designers have improved to hold their stiffness better, often through coatings. But you know what? They have different breakup behavior. And the real key is, there's an example. These two different materials, whatever metal you're using, it's not just one type of metal dome tweeter. There are many types. Or whatever soft material you're using, or whatever in between, they're going to have different behaviors that are measurable and, yes, audible. So one example alone is enough to blow apart this argument that speaker driver materials, particularly diaphragms, don't matter. But I want to bring in one other aspect of materials that many people don't consider: the weight, and how that affects both the measurements and, once again, the sound you hear. And so let's say somebody finds what they think is an ideal material because it holds its shape not only within the audio band, but far beyond the audio band, octaves above, and its flat frequency response way out there. But it's heavy. All things being equal with the driver and the motor system, that heavier diaphragm will mean the motor system won't get the same output level than with a lighter diaphragm. So what that means is you have to give the driver more power to get the same output level. Not a big deal because power comes cheap these days. However, more power usually comes with higher heat from the driver, more distortion, more compression. Things that are both measurable and once again, audible. So I could belabor the point about the differences materials for drivers make, particularly the diaphragms, but I don't want to belabor that point. Just know they do make a difference for the reasons I told you and other reasons beyond that. And also know this, if somebody says otherwise, they have no clue what they're talking about. Thanks for watching. I hope this helped.